In this short video, we'll focus on calculating missing angles, interior angles in polygons. We will be looking at both regular and irregular polygons. So the first thing is that until we see in the diagrams or which go with the questions, those little lines which I'm just drawing on the screen, we don't assume that the polygons are regular. So those lines are indicating also most of the time in the questions themselves they tell us calculate the missing angle in this regular polygon, or this polygon is regular. Now, regular polygons are equilateral triangle. The regular quadrilateral is just a square, regular polygon, regular hexagon, and so on. Now, the formula for the sum of all interior angles in a polygon with n sides is n minus 2 multiplied by 180. And the reason is that from one point in any polygon, we can always make two less triangles than the number of its sides. So if I draw these lines from one point in any of these polygons, what we notice that when we got quadrilateral, we have two triangles. So it's two triangles, two less than the number of the sides. When we're looking at the pentagon, from one point we can make three triangles. So it's always two less than. In the hexagon, we can make four triangles from one side. It's always two less than. So that's why the formula for the sum of all the interior angles is n minus 2. So the number of sides of the polygon take away 2 multiplied by 180. And again, I'm going to write down here that n stands for number of sides. Now, if we have got a regular polygon, then to work out the size of just one angle, we use the same part of the formula from above, which is n minus 2 multiplied by 180, and we divide that by n. So we just divide by how many sides or how many angles does the polygon have, because obviously they're all equal, so you find the sum of the interior angles divided by the number of angles or number of sides. So let's put that in practice. Find the sum of all interior angles in a polygon with 10 sides. So I'm going to use the formula for the sum, so reading the questions carefully, and that is n minus 2 multiplied by 180. And when n is 10 here, for the 10-sided shape, we do 10 minus 8, 10 minus 2, sorry, I'm thinking ahead there, multiplied by 180. That is 8 multiplied by 180. And that is equal to 1440 degrees. So that is the sum. Right. So now, if you're watching this video and you'd like to have a go, you can pause it and you can work out the sum of all interior angles in a 13-sided polygon. Okay, so hopefully you did that. I am going to move on to calculating the size of just one interior angle of a regular polygon with 9 sides. So again, looking at the formula which we should know by now, I'll be using the formula first for the sum, and then I'll divide by the number of sides or number of angles. And in our cases, n is equal to 9. So we'll do 9 minus 2. I'm just substituting that. Multiplied by 180. Because I've got to remember 7 triangles from one point, each 180 degrees worth, and I'm going to divide that by 9 because there are 9 angles in the 9-sided shape. So, or in the nonagon, that is 7 multiplied by 180, and you can use your calculator for this most of the time. Sometimes they come up on non-calculator papers as well, but they wouldn't want to trick you with divisions. And when you divide it by 9, that is 140 degrees. So just to summarize, 140 degrees is the size of one interior angle when the nonagon, so this 9-sided shape, is regular, for a regular nonagon. Now, if you'd like to have a go, you can try and calculate the one side, the one angle, so the size of one angle in 11-sided shape. Pause the video and have a go. Right, so now we can move on. Let's put this in almost exam question, more complex situations. The diagram shows a square and 4 regular pentagons. So the first thing you know is, since they're telling you that this is a square, it just means that all these sides are equal, so that's the keyword, and a regular pentagon. So what it means that is the length of the square is also one of the lengths of the pentagon. And what we'll do now is, what do we know? We know that the square, this one of the angles is 90 degrees, so I'm just going to label that. And since we're looking for the size of angle X, which I'm going to kind of highlight here a little, let's first focus on working out what is the size of one interior angle in a regular pentagon. Since we've got two pentagons, so two interior angles in a pentagon, a square and angle X as angles at one point. So the formula we're using, again, is we're looking at the size of one angle in a regular pentagon. So we'll divide that by n. So our n is 5. I'm going to substitute. So we do 5 minus 2 multiplied by 180. Divide that by 5. So that is 3 times 180. And we'll divide that by 5. And that gives us 108 degrees. And now let's see what we've got. So with this angle here is 108 degrees. This angle here is 108 degrees. So now we are looking at angles at a point. So let's focus. 108, 108. We got the 90. We should all know that angles at a point add up to 360 degrees. So let's add them. So we got 108 plus 108, because the 208 interior angles in a pentagon, in a regular pentagon, and 90. Let's add them up. And then we will take them away from 360 degrees, and that will give us angle, the size of angle X. So that is 306 degrees, and let's take it away from 360. So that's the sum of the 3 we just found, and that gives us 54 degrees. And that's your final answer. I'm just going to label here. That's full mark question. Full mark questions, very common. They come up on every GCSE paper, but the content is something that's covered in Key Stage 3 and Key Stage 4. And as soon as you kind of you've looked through and worked through this question, you can now look at the next question, read it carefully, and pause the video and have a go. And finally, last but not least, is working out the missing size of missing angles in irregular polygons. Now, the formula n minus 2 multiplied by 180 works for any polygon. The difference is that when the polygon is irregular, we cannot really divide by the number of sides and number of angles, because they're just not equal. So when you see a question where you've got to work out the size of interior angle in an irregular polygon, the first thing is, let's see what do all angles add up to in this polygon. So we're looking at 1, I'm deliberately not drawing the lines, 2, 3, 4, 5, 6. So this is a hexagon. So I'm going to apply the formula above. So n is 6, just to work out what do all angles add up to. And that will be equal to, let's see, 4 multiplied by 180 is equal to 720 degrees. And now, why don't we add all the angles that we know, 100 and 135. So when you add them, they should add up to, let's do that, 595 degrees. So that's the sum of what we know already. Well, now finally to work out x, what do? We do 720 minus 595, and that will be equal to 125 degrees. So just to summarize, we were just looking now at the last part where we calculate missing angles in irregular polygons. And to do that, you use the same formula because that applies to any polygon n minus 2 times 180 degrees, which is the sum of all interior angles. And then you just add the angles which you know and take them away from the sum to work out the size of angle x of the missing angle. Right, and finally for you, look at the next question. Here we go, and complete. As soon as you're ready, you can just put down all the formulae that we just went through. Lots of love from me and Tutoring Champions. It's Emilian. All the best. Next video will follow on calculating the exterior angles and looking at links between the interior and exterior angles in Polygon.